Hey everybody, so we're going to start the second target in surface area. So this one we're going to deal with spheres and composite solids. So I'm going to introduce composite solids in this video, and in the next video I'm going to go more into it. So the only figures we haven't talked about yet are a sphere and a hemisphere. So the surface area for a sphere is 4 pi r squared. That is the formula for the surface area of a sphere. Now, a hemisphere, you need to think about. Surface area is all about the figures that you can touch. So if you'll notice, the surface area of a hemisphere is broken up into two parts. It's the dome. It's the dome part. So the dome part, which is down here. Okay, that's if you cut a sphere in half. So that's 2 pi r squared. That represents the dome. And then we have a disk. We have a circular disk on top, which is just a circle. So that's pi r squared. That is the disk or the base. It's the base of the hemisphere. So the total surface area for a hemisphere is 3 pi r squared. Okay? So find the surface area of the sphere or the hemisphere. In A, we're dealing with a sphere with a radius of 4. So surface area is going to be 4 pi r squared. So that is going to give us 64 pi yards squared. Or if we wanted to do approximate, that would be 201.062 yards squared. For a hemisphere, the radius is 5. So the surface area is going to be 3 pi r squared. So that's going to be 75 pi feet squared, or around 235.619 feet squared. Okay? Surface area of a sphere is 110.25 pi square feet. Find the radius. So we plug in surface area for surface area, 110.25 pi. And we're dealing with a sphere, so that's going to be equal to 4 pi r squared, since we don't know what the radius is. We're going to divide both sides by 4 pi. So 110.25 pi divided by 4 pi. The pi's are going to cancel out and leave us with 27.5625 is equal to r squared. We are going to square root both sides. And when we do that, the radius is going to be 5.25 feet. So that introduces spheres, hemispheres, and surface area, which we're going to use when we're dealing with composite solids. So if you remember when we found area of composite solids, we broke up the figure into different parts that we could find the area for, and then we added or subtracted to find the area of the total figure. Same idea here with composite solids, except we need to think about what surfaces can we touch? If this figure was in front of us, what could we touch? So this composite solid is two parts. It is a cylinder. It's part of a cylinder. And it's part of a hemisphere. Okay? Now, for the cylinder, what can we touch? Well, we can touch the bottom base. And we can touch the lateral surface area, which is the part that wraps around. So the lateral surface area. So if you remember, the surface area of a cylinder is 2 times the area of the base plus the perimeter of the base times the height. So what part do we not need? We don't need 2 bases. We just need 1 base because we can only touch this bottom base. We cannot touch this base right here. So I'm going to erase that because we can't touch it. So if I wanted to do that, area of the base, that's pi r squared. Radius is 6, so that's 36 pi. Perimeter of the base is 12 pi. The height is 13. Height of that cylinder is 13. So if I plug that into the formula, I'm going to get 36 pi plus perimeter of the base, 12 pi, times the height, 13. I'm going to leave this as exact for now, which means involving pi. So the cylinder part is 192 pi. This is going to be an important part. Now, for the hemisphere, we only need the dome because we can't touch the base or the disc part of the hemisphere. So that's going to be, not 3 pi r squared because it's just the dome. That's going to be 2 pi r squared. So that's going to be 2 pi, radius is 6 squared. So that's going to be 72 pi. So to find the composite solid, we are going to take the part of the cylinder that we want, which is 192 pi, and then we're going to add the part of the hemisphere that we want, which is the dome, which is 72 pi. So that is going to give us an exact answer of 264 pi inches squared, which approximately is 829.38 inches squared. That is how we deal with a composite solid. Composite solids with surface area are tricky. You need to think about what surfaces you can touch. So you start with the surface area of the figure and then think about what can you touch and what can you not touch. Because if you can't touch it, you don't want to involve it in the total surface area. Okay? If you have any questions, let me know. Other than that, you can get started working. Next video, I will go over some more composite solids.